Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic One. In this video, I will be doing a walkthrough of HackTheBox's vulnerable host broker. I'll provide a step-by-step walkthrough of the entire attack chain, covering reconnaissance, exploitation techniques, including file upload and remote code execution, system misconfiguration analysis, and privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on cybersec.com. Broker is a vulnerable host created by Carmelo to allow users to practice ethical hacking techniques. This virtual host is accessible from the HackTheBox virtual training lab. I've started the target host broker, and as seen on the screen, it now has an IP. The first step in the process is information gathering, which includes performing port scans and enumerating the available services. For active information gathering, I typically use nmap. I'll run the following commands shown in the CLI. The goal here is to identify which ports are open. To do this, I'll scan all 65,535 ports using the -p- switch, ensuring I don't miss any services that may be running on non-standard ports. Reviewing the nmap scan results, I found the following open ports: port 22 SSH, port 80 HTTP, port 1883 MQTT, port 5672 AMQP, port 8161 HTTP, port 37519 TCP wrapped, port 61613 STOMP, port 61614 HTTP, and port 61616 Apache MQ. These open ports indicate a variety of services running on the target host, each potentially offering different attack vectors to explore further. The target host broker is likely running a Linux-based operating system. Nmap identified the OS and CPE as a generic Linux distribution. Additionally, the service banners for SSH and HTTP both indicate Ubuntu. Let's now take a closer look at port 80. From the nmap output, I can see that the web server is running Nginx version 1.18.0. The scan also returned an HTTP 401 unauthorized status code, which typically suggests that the page requires authentication. The nmap output also specifies the basic realm equals ActiveMQ realm, indicating that the authentication realm is related to ActiveMQ. The ActiveMQ realm refers to the security configuration for Apache ActiveMQ, an open source Java-based message broker. ActiveMQ uses various authentication and authorization mechanisms to secure its instances, including LDAP integration and Java authentication and authorization service. Key security features for ActiveMQ include authentication. Verifies users' identities through methods like simple authentication, LDAP, and JAAS. Configuration is typically managed in files such as jettyrealm.properties and login.config. Authorization controls users' access based on roles with configurations defined in the authorization plugin section of the ActiveMQ.xml. Encryption ensures data security both in transit and at rest, supporting encrypted passwords and SSL TLS for secure communication. Run the following FUF command shown in the CLI to crawl the web server and search for hidden directories. The -u and -w flags are straightforward. The -u specifies the target URL, and the -w points to the word list. The -fc flag is used to filter out responses with status codes 401 and 403, effectively excluding unauthorized access errors from the results. FUF came back with nothing useful. Fuzzing the web server didn't yield any valuable information, so I decided to manually explore the website. When I navigated to http://10.129.42.1, a login prompt appeared. When I click cancel, I am redirected to a page displaying a 401 status code. The page also shows the version of Jetty being used, as shown in the browser. I did a Google search for ActiveMQ default password, and Google immediately brought up admin. Let's attempt the default credentials and see if I get low-hanging fruit. The default credentials worked and I was able to log in. I get brought to the ActiveMQ page containing several links. Clicking on the Manage ActiveMQ Broker link brought me to the broker page that displayed the version as 5.15.15. At the top of the page, there are several links. I explored each link looking for useful information, but nothing of interest stood out. While browsing the web application, it didn't seem like there was an obvious path to access the target host. I decided to Google for ActiveMQ 5.15.15 exploits. I got a few hits in the Google results. Several sources in the Google search results reference CVE-2023-46604, a critical remote code execution vulnerability in Apache ActiveMQ. This flaw allows remote attackers with network access to a broker to execute arbitrary shell commands. The vulnerability exploits the manipulation of serialized class types in the OpenWire protocol, causing the broker to load and execute any class available in the class path. Reviewing the Google search results, I proceeded to examine the following GitHub repository shown in the browser containing a proof-of-concept exploit. After reviewing the README file on the GitHub repository page, I could see that it includes the necessary commands to exploit a Linux host. After reviewing the poc-linux.xml file, I can see that the proof-of-concept is designed to execute on the target host, triggering it to initiate a curl command that connects to my HTTP server to download the MSF Venom payload. The script then instructs the target host to modify the payload's permissions, making it executable. To ensure that the exploit functions properly, I had to rename the payload to exploit.elf and update the IP address and port to match those on my HTTP server. Having reviewed the proof-of-concept exploit, I'll download the repository by clicking on code, then the copy icon. With the GitHub repository URL copied, I can now run the git clone command to complete the download of the repository. I'll run the following command shown in the CLI. As noted earlier, I modified the exploit script by renaming test.elf to exploit.elf and also entered my HTTP server IP as shown on the screen. I ran the following MSF Venom command shown in the CLI to generate my payload. If the target host is not x64 architecture, be sure to change your payload to an x86 version. With my MSF Venom payload generated, I went ahead and started my HTTP server as shown in the CLI. I also started my netcat listener to be ready to catch a shell if my exploit works. With all that said, I'll run the following go command shown in the CLI to execute the ActiveMQ exploit. After executing the exploit, my netcat listener successfully caught a shell from the target host, as confirmed by the session created from the target host IP. I proceeded to run the whoami, pwd, and ls-la commands to identify the user account in use, check the current directory, and list the contents of that directory. The output indicated that I was in the /apache-activemq application folder, where I also spotted the MSF Venom payload I had generated earlier. With the initial foothold established, I began host enumeration. I used the cd tilde command to navigate to the home directory of the current account. To confirm the working directory, I ran the pwd command, which indicated that I was in the ActiveMQ directory. Finally, I executed the ls-la command to list the contents of the folder. Among the items, I discovered the user.txt file, which contains the first flag. To retrieve the first flag, I executed the cat command on the user.txt file. After documenting this information, I can now proceed to explore the target host further. With the first flag retrieved, the next step is to escalate privileges in order to locate the second flag. A straightforward way to identify potential escalation paths is by running psng. If psng isn't available for some reason, there are alternative resources available. For instance, I can use the TJ Knowles Joplin template or review privilege escalation documentation available with a Google search. Since I already have linps in my downloads folder, I'll run the following wget command to upload linps to the target host. Based on the output, linps was successfully uploaded. I then used the chmod command to adjust its permissions, allowing me to execute it on the target host. To confirm the changes, I ran the ls-la command and verified that the permissions were updated correctly. With the linps now on the target host, I'll run the following linps command to start automated host enumeration. The -a command runs all checks, and the -e command runs extra checks. Reviewing the linps output, it appears that the sudo-l check detected that nginx can be run as root without a password. As noted earlier, linps output showed that the ActiveMQ user was able to run nginx as root without a password. Investigating further, I searched Google for the sudo output, which returned several potential options for testing. I reviewed the privilege escalation-nginx/sudo GitHub page, which highlighted that sudo permissions for nginx are key to successful escalation. The page also showed the same sudo permissions that I identified using sudo-l on the target host. Before utilizing an exploit, I prefer to understand its execution. By examining the script, I can break down its operation. The script initially generates a new nginx configuration file located in the /temp folder titled nginx_pwn.conf that runs nginx as the root user and sets up a web server that listens on port 1339. This web server enables directory listing and allows put requests, which can be exploited to upload files. Next, the script uses sudo to run nginx with the newly generated configuration file, effectively launching nginx as the root user. The script then generates a new SSH key pair using the ssh-keygen command. The private key is displayed for easy copying. Finally, using the put request to the nginx server, it adds the generated public key to the root user's authorized keys file, granting SSH access as the root user. The script should be saved as a bash script that can be run on the target host, such as exploit.sh. Note that the private key should be saved as a file named id_rsa. After saving the key, it notes to run chmod 600 on the id_rsa file to ensure the proper permissions are set for secure login. Rather than executing the script, I opted to break it down into smaller components to gain a better understanding of the exploit, beginning with creating an Nginx configuration file called privesc.conf, using the exploit script I downloaded from GitHub as a template. In case Nginx was running, I modified the PID to Nginx3 and changed the service port to 8181. I uploaded the Nginx conf file I created using wget. Based on the output, it was uploaded successfully as shown in the CLI. With the Nginx conf file uploaded to the ActiveMQ application folder, I ran the following command shown in the CLI. Following the exploit script, I now need to generate SSH keys. I ran the SSH keygen command as shown in the CLI. After running the command, I get prompted for a location where the keys will be stored. Since I am in the ActiveMQ application folder, I just entered ID_RSA, which will place the SSH keys in the ActiveMQ application folder. I then set the passphrase for the keys to password. Once completed, the SSH public and private keys were successfully generated. With the SSH keys generated, I wanted to transfer the keys to my system. I started the netcat listener on port 4444 in order to download the ID_RSA file I generated. On the target host, I ran the following netcat command shown in the CLI to connect to my system. Wait 3 seconds and upload the ID_RSA file. I ran the same netcat command to transfer the ID_RSA.pub file as well. After obtaining the SSH keys, I ran the following curl command shown in the CLI from my system to add the public key I generated to the root account's authorized keys file. The upload appeared successful based on the curl output. I now need to change the permissions of the ID_RSA file in order to use it to authenticate to the target host. I ran the following command shown in the CLI. With the permissions modified for the ID_RSA file, I'll run the following SSH command shown in the CLI to attempt to connect to the target host. After hitting enter, I get prompted to enter the ID_RSA passphrase. I typed password and hit enter, and it looks like authentication was successful. As can be seen in the CLI, I am now logged in as the root account. I ran the cd tilde command to change directory to the root home folder. I also typed ls-la to view the contents of the root home directory. One of the files displayed is the root.txt file containing the final flag. I ran the cat command on the root.txt file in order to view the file contents. I was able to capture the final flag, and I have completed the host. On a side note, because of the Nginx configuration file I created, the web service is running as root. This means when I browsed to port 8181, it displayed the root directory. This allowed me to navigate the target host's directory structure from a browser. For instance, I could go to the root home directory and view the root.txt file. I could even navigate to the Etsy shadow file and view the contents. In conclusion, by employing a variety of techniques, I was able to progress from reconnaissance to gaining root privileges on the target host. These steps enabled me to gather the necessary information to establish a foothold using default credentials, arbitrary file upload, and remote code execution. Once I gained access, further enumeration revealed a viable privilege escalation path, which I exploited by abusing sudos to ultimately obtain the final flag. Thank you for tuning in to this demonstration of HackTheBox's Broker Vulnerable Host. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic1, signing off.